Hello everyone. My name is Paulo, and I'm here to present this work named Split and Rephrase in a Cross-Lingual Manner, a Complete Pipeline. This work was made with the collaboration of my advisor, Professor Evandro Ruiz. We are from Department of Computer Science and Mathematics from University of São Paulo in Ribeirão Preto City, State of São Paulo, Brazil. Uh, First of all, we need to specify the split and rephrase task. What is the goal of the split and rephrase? We can say that it is a task that promotes the transformation of a given complex input sentence into multiple shorter sentences. This requires the meaning preservation from the original sentence in the multiple sentences. So basically, split and rephrase task conceptualizes that shorter sentences benefit human reading and may also improve natural language processing related tasks. For example, being useful as a preprocessing step. So, that being said, split and rephrase can be considered a text transformation within the sentence simplification task. Sentence simplification task can help people with limited language skills, such as those with low education levels, children, non-native speakers, and people with learning impairments, and may also improve the performance of other tasks, such as parsing, machine translation, semantic role labeling, text summarization, information extraction, among many others. And it is widely accepted that sentence simplification seeks to solve two main aspects: the lexical complexity and the syntactic complexity. From the split and rephrase perspective, neither deletion nor lexical or phrasal simplification is intended. Actually, the core of the process is to properly make the syntactic transformations required by the split action. For example, turn a relative clause into a main clause. So we can see a basic example here. The example shows a unique input sentence broken into two output sentences. We can see the transformations involved in the highlighted words. The pronoun it is placed in the second sentence to refer this bottle in the first sentence. So, concerning split and rephrase main tasks, we first highlight the recent work from Narayan, which proposes the task. This work presents data-driven baseline models to help with insights about split and rephrase, and also introduce the web split corpus, a proper corpus to train, validate, and test new models. After that, Arahoni and Goldberg released a new version of the web split corpus to reduce overlap in the data splits, and also proposed stronger baselines with sequence-to-sequence models augmented with copy mechanism. Basically, the copy mechanism forces the models to copy specific tokens from the input to the output sentences. And in addition, the work from Bota compiled the weak split corpus. This dataset reunites more than 1 million rewrites obtained from the history of Wikipedia. Compared to the web split versions, the weak split corpus has a large vocabulary and also more natural linguistic expressions. And at last, the work from Niklaus constructed the min-weak split corpus. It applied a set of 35 fixed handcrafted rules in the weak split data to decompose the source sentences in more regular outputs. And yes, we used all of this for mentional English corpora in this work. So about this work, we present a complete pipeline capable of performing the split and rephrase challenge. By combining trained sequence-to-sequence neural models with BERT's masked language modeling. And to train these sequence-to-sequence models, we rely on symbolic vocabularies, which we'll explain soon. And in addition, this proposed pipeline seeks to deal both with English and Portuguese sentences. And to the best of our knowledge, this is the first complete work to address split and rephrase in a cross-lingual manner. So first talking about the sequence-to-sequence models, they were based on the conventional encoder-decoder architecture composed of GRU neural networks with attention mechanism. Basically, the attention mechanism establishes references in the original sequences and enable the transmission of them to the decoder. And yes, this approach is known to be a good strategy for training models in aligned corpora. And yeah, ideal for natural language generation tasks also. In our procedure, we train these models with symbolic vocabularies. Uh, so in our implementation, the symbolic vocabularies were composed of symbols acquired by the concatenation of word classes and their recurrences observed in the aligned pairs from the training data. Uh, we can see in the figure the collection of gained symbols from a given alignment. We put together a unique copy of each symbol to compile the final vocabularies. And then we train the models using the respective vectors of symbols. Yeah, we found this strategy drastically reduced the vocabulary size and optimized the training times. And since our models are trained with symbolic sequences, they will predict symbolic sequence, of course. So a reconversion process to genuine texts is demanded. So we employed the masked language modeling from BERT to fill the gaps after the reconversion process. Actually, this is a powerful modeling to foster new tokens according to the context. We can see in this example the symbols being replaced by corrected words. On the left, we mask each of these symbols while executing the predictions to fill the gaps. And on the right, we see the final output after the complete execution. Yeah, so regarding the data involved to train, validate, and test our pipeline, we had these numbers. We used 5 data sets. This means all the English corpora already mentioned before, and also the per simply sent set. The per simply sent set is a proper corpus for readability assessment in Portuguese. And in this work, we did an extraction of its data to capture alignments with split sentences in the simplified side. So we then use it as references to test the pipeline in Portuguese language. For training purposes, we used both weak split and min-weak split trained sets. And to test the pipeline, we use both web split versions, the weak splits and the parsing percent sets. So regarding the two different sequence-to-sequence trainings, the first one was executed as from the weak split training set. We selected sentence pairs formed only by alphanumeric chars, commas, periods, and white spaces, as this corpus is slightly noisy as admitted by the authors. And the second training was executed as from the min-weak split corpus. In this case, we established a limit to select a line sentence with a maximum length of 100 tokens. And we then again executed the same previous selection to avoid potential noises. So in the end, both vocabularies counted around 200 symbolic items. This table shows the numbers obtained by the pipeline, considering the two different trainer models. Following the previous split-and-rephrase works, we report the results in sentence level through BLEU. BLEU is a known metric for n-grams precision estimation borrowed from the machine translation task. Also following previous works, we report the average number of simplified output sentences per complex input sentence, and also the average number of tokens per simplified output sentence. And lastly, we report the percentage of outputs totally copied from the input without any modification. So we inspected some of the predictions from the different setups to find out some of the general patterns produced by the pipeline. And in this example, the output one from the first setup created the pronoun he in the second sentence, thus making a relation to Christian Panucci in the first sentence. On the other hand, output two produced Christian Panucci again instead of using the pronoun. Yes, and this illustrates different kind of knowledge gained from the training in weak split and min weak split sets. And even though the outputs are different, both were split correctly. And now checking another example, this time in Portuguese. We can see that similarly to the last example, the output one created a pronoun ele or he in English. And the output two repeated the words o projeto Gemini or the project Gemini project. So it is exactly the same behavior seen in English and in Portuguese sentences. And yes, we could show many examples here, but we quickly brought these ones just to illustrate the cross-lingual manner in action and to show the ability of the pipeline in performing equivalent syntax transformation from different languages. So yes, we conclude that our proposal could split sentences, often preserving the original meanings. We established our pipeline as a competitive method. The pipeline tends to explore the syntax-based patterns behind splitting in both English and Portuguese languages. Unlike most works on split-and-rephrase, we employed the four state-of-art corpora for the task and also a Brazilian Portuguese corpus. And as a limiting factor, we point the noise observed in the test sets. We note that some of the invalid references harmed the BLEU scores in some cases. And as future work, we plan to exploit our pipeline in more languages. So that's it. Thank you very much.